again. I ran into some really weird problems with my tablet when I tried this. So here we go. We're going to look at efficient buying with bulk pricing. And I've kind of hashed over this with some things, but in particular, let's sort of look by doing by hand what we're going to do in the project. Okay, we won't use the exact same set of items or anything, but suppose you've got bulk pricing. And you look at something and you say, oh, okay, yeah, if I buy one, so my quantity here, price each, maybe one thing would be $10. And then though, if I buy 2 to 5, well, then price each is just $7. If I go 6 to 10, maybe I can get them for $5 each, and then maybe 11 to 20, $4 each. Okay, now for each of these, I could write a function, a straight line function, or a model. This one would be y equals 10x, because for every x I pay $10, or for every item I pay $10. This one I could write as y equals 7x, y equals 5x, because they're $5 a piece, and y equals 4x. So see, there we're getting mathy. But I can put this all together as one function. I can say, oh, this is a piecewise function. And so y equals, and I have my 10x, I have my 7x, 5x, 4x. But now I need to tell you when to use each of those. And so, here would be like x equals 1. Then from 2 up to 5 it was, I would use 7x. From 6 up to 10, I would use 5x. And then from 11 to 20, I would use 4x. How much would 21 be? I don't know. It's not in here. So maybe it's undefined or something like that. But, okay, so there I've just made a model of this bulk pricing. That's a nice model and so forth. It would tell me exactly what to do for the number of items. But the problem is it's not efficient. And by that, all I have to do is say, look at, buy 10 at $5 each for $50. Right? So that would have been, if I wanted 10, I would have gone here and it would have said $50. Well, that would have led me astray, because it turns out if I buy 11 at $4, that would be for $44. I just saved $6 for the 10 I needed. Plus I got an extra one that maybe I could sell on eBay or something like that. If I really didn't need it, I could resell it. So I could, in that way, maybe save even more money. So it really doesn't make sense to buy 10 items. And what I'd really like to do is change my model here so that it doesn't make me lose money. And so what I'd like to do is do that. Because now if I went to buy 10 items, it would tell me, don't buy 10 items. You can buy 9 or you can buy 11. Don't buy 10. And what I would do then is, well, if I can't buy 10, I would go to 11, probably, because I need 10. So I would go ahead and buy the 11 and pay the $44. And this kept me from losing money by redefining my model this way. Okay, so what we want to do is look at graphically, how can we do that? Because this is algebraic language. And it is very, very nice, a very nice language for me to know how to calculate. Algebra is great to help me with calculation. Awesome. But visually, I can't really see what's going on. And so what we want to do is translate to graphical or visual language. And then we'll be able to use that to help us get rid of any over buying we would do, any wasteful buying that we would do. Okay, so we would go to a graph. Now mine's going to be by hand, so it's not going to look great. But let's see. So I need to go to 20. So we'll call that 10, that 20. So that'd be 15, 5, and then 6, 7, 8, 9, 1, 2, 3, 4. 1, 2, 3, 4, 6, 7, 8, 9. Of course, my spacing's a little off. 11, 12, 13, 14. And I won't fill in the 15 to 20, but 11, 12, 13, 14. So we have that. And then this would need to go up to like 80, I guess, for $20 at $4 a piece. So I'll try, maybe that's 10, 20, 30, 40, 50, 60, 70, 80. Okay, 10, 20, 30, 40, 50, 60, 70, 80. Now, and I can draw each of these lines just by drawing their basic points. Now, 1 at $10. So there's that first model, and I could draw it, down to the origin if I wanted, although we haven't said you could buy half an item or something like that. But this would be y equal 10x right there. Then from 2 to 5, that was 7x. And so 2 times 7 is 14, so that would be right about there. 7 times 5 is 35, so that would be maybe about there. And it's not quite as steep a slope as the 10x, and there's y equals 7x. Then 6 was times 5, so that goes to 30. Up to 10, that's somewhere around 50, I guess, right there. And so I think that's y equals the 5x. And then finally, 11 here would go to about 44. We'll put that there. And then all the way up to 80 for this one. Okay, and there's y equal 4x, but only for the parts that matter. Okay, now visually, what I can see is if I work in from the left this way, I can see that this price, okay, this price, total price paid, is lower than that price. I can just see it visually. It's right there. It's lower on the graph. And so I don't want that price. Well, that's the whole 10 at $50, 11 at $44, and I can just see it visually. Well, so what I can do to help me with this, I'm going to erase those items there so I can draw. Well, I guess I could keep that. I'm coming in from the left. So if I draw this 11 times 4 is 44. If I draw y equals 44, that will be, 44 is about there. That will be this straight line coming across. That's supposed to be a horizontal line. And what I will see is that it cuts across right here. And so I never want to buy anything right in here, this stuff. I don't want to buy that because it would be cheaper to pay the $44. Now I can look at the graph if I look at where these intersect and just I'm in something like Desmos or whatever, what I will see is that this is between 8 and 9 somewhere. Okay, I think it'd be like 8.8 or something like that, and so, this point here is something like the 0.8 and 44. Well, what that tells me is get rid of 9, get rid of 10. Okay, because I don't want to buy 9 or 10 because, if I hit 8.8 items, I can't, but if I were to hit 8.8 items, it would be $44. So I don't want to pay for 9 or 10. And so then what I do is, I get rid of that and I only go here to 8. And so this is from 6 to 8 now, and this is still 11 to 20. Whoops, 20. Now I've gotten rid of anything that was more expensive there. And then I do the same thing. I move now to this one and I say, oh, okay, that is lower than, well, okay, that was 6 times 5 is 30. That's this one. And that cuts off here. And again, if I check, this is going to be between 4 and 5. I don't know exactly where, but we'll keep 4. But I definitely don't want that 5 there because 5 times 7 is 35. So that's going to go away. I'm going to get rid of the 5, but I'll keep the 4 I would see on the graph because 4 times 7 is 28. And so I'm going to get rid of that stuff and go to here and see, and I'll get rid of that 5. And so this now goes from 2 to 4, but you see it's higher than the 10 here at 1, and so I'll keep the 10 at 1. And so with all those, let me put you on pause a minute. Okay, I'm back. My grandson came in, wanted to talk a little bit. I didn't think you all wanted to hear our conversation. Well, actually, you might have wanted to hear our conversation. They're often kind of interesting, but at any rate. So we've gotten rid of the 5, the 9, and the 10, so I can rewrite my model getting rid of those. And so I still have the 10x right there. And that still is when x equals 1. Now I still have the 7x. That's this next one. And that now goes, instead of from 2 to 5, it goes from 2 to 4. And then I still have the 5x, and that's my third one. But it now just goes from 6 to 8. And then finally the 4x didn't change because that was just the cheapest rate to buy anything. And so it'll never change, being the cheapest rate. And that's what I get. But you see now, those two items have changed there, because if I come in and I say I want to buy 4 items, oh yeah, I pay $7 a piece and pay $28. But if I wanted to buy 5 items, this would now tell me, oh, you can't buy 5 items. Well, of course you can, but it's telling me don't buy 5 items. So if I wanted 5, oh, I would go to 6 and pay the $5 a piece for $30. Right? So here, you know, I would see y of 4 is equal to 7 times 4, or 28. I would see that y of 5 is undefined. Okay, so I wouldn't do that. And so I just go up to the next item, you know, the next thing I could do, y of 6 is equal to 5 times 6, which is 30. And I pay $30. Now, I worked from left to right, and the reason you want to work from left to right is, let's do a quick visual of something that can happen, and this actually does happen in your project with those prices for the tattoos. Is that you could have something coming way down to there, and, you know, say this other piece going like that, and then, whoops, I did those backward. Let me get those going right. The steeper one should be closer in. Now, so let me draw it this way. And then, you know, I might have something here that goes like that, and then something here that goes like that. So those could be my 3 segments. Well, notice if I come in from the left and I draw that y equals whatever this value is here line to go across there, what I see now is actually that whole segment just needs to disappear, because it's totally above this line. And so if I come in from the left, I can do that nicely and just get rid of that all at once, and come way over to here and get rid of this part as well. And so now I would have this big gap in here where nothing's defined, because none of those would be efficient prices to pay. And this actually happens in a couple of spots with that bulk pricing tattoos. I think I reduced your data set a little bit, so it may only happen once, but I think it happens twice in your data set. There are 2 places where you want to get rid of a whole section, and so you just wouldn't have it anymore. So, you know, for instance, let's suppose this used to go to 2, and then that was from 3 to, you know, who knows, maybe that's 10, and then that's 11 or something like that. You know, you would have had a y equals, and you would have had 3 things, and, you know, I'm not going to put those parts in, but you would have had, say, from, you know, 0 to 2, and then 3 to 10, and then 11 up to something. Yeah, we'll just go to 20 again. Right? You would have had that, but when we look at this visually, we would have seen that that just would have disappeared. We won't have that anymore, and this looks like it would probably go down to 1. And so we would just have, if you want to buy 1 item, you would pay whatever the rate was there. And if you wanted 2 to 10 items, you would actually buy 11 and pay whatever rate is there, because it would have been cheaper than buying 2 items or 7 items or something like that. Okay, that is what we're doing in the project, and that's why we're working in from the left, is because we could end up just getting rid of a piece, a whole piece in there, and we will. So there we go. That's that video.